Saarloha Advanced Materials Private Limited, a hallmark of special steel quality. Founded in 1973, Saarloha over the years has matured into a premier supplier to core sectors like defense, aerospace, nuclear, automotive and engineering.
Steel signifies the growth of a nation. Sunflag Iron and Steel Company Limited, manufacturers of world-class automobile, defense and engineering grade steel.
Saarloha Advanced Materials Private Limited, a hallmark of special steel quality. Founded in 1973, Saarloha over the years has matured into a premier supplier to core sectors like defense, aerospace, nuclear, automotive and engineering.
Steel signifies the growth of a nation. Sunflag Iron and Steel Company Limited, manufacturers of world-class automobile, defense and engineering grade steel.
Saarloha Advanced Materials Private Limited, a hallmark of special steel quality. Founded in 1973, Saarloha over the years has matured into a premier supplier to core sectors like defense, aerospace, nuclear, automotive and engineering.
Steel signifies the growth of a nation. Sunflag Iron and Steel Company Limited, manufacturers of world-class automobile, defense and engineering grade steel.
Saarloha Advanced Materials Private Limited, a hallmark of special steel quality. Founded in 1973, Saarloha over the years has matured into a premier supplier to core sectors like defense, aerospace, nuclear, automotive and engineering.
Steel signifies the growth of a nation. Sunflag Iron and Steel Company Limited, manufacturers of world-class automobile, defense and engineering grade steel.
Saarloha Advanced Materials Private Limited, a hallmark of special steel quality. Founded in 1973, Saarloha, over the years, has matured into a premier supplier to core sectors like defense, aerospace, nuclear, automotive and engineering.
Steel signifies the growth of a nation. Sunflag Iron and Steel Company Limited, manufacturers of world-class automobile, defense and engineering grade steel.
Dr. Sanjay is yet to join. We will wait for him meanwhile. Good afternoon, namaskar, hello, and welcome everyone. I'm back with a new program today after 10 days, which clearly shows our lives are coming back to normal, but not too normal. The pandemic is not yet over. We still have cases. We still have new wave at the corner. Please take utmost care of yourself and your loved ones. Thank you for joining us for today's webinar. My name is Monica Bachchan. I'm a founder of Metalogic Projects Management Services. It is a maximum women staff organization. We call it a women staff organization because 80% of our staff are women. Today on 23rd July 2021, we are presenting you a webinar on Indian alloy steel, sponsored by Arjas Steel and associate partners Sunflag Steel and Saarloha. This is our 34th webinar during COVID-19 pandemic. I hope you gained an insight from our last webinar on stainless steel for bridges and flyovers, a safer and sustainable solution, held on 13th of July. The recording of that webinar is available on Metalogic PMS YouTube channel. Please do not miss to subscribe to our YouTube channel. It's youtube.com/metallogicpms. This webinar is currently live on YouTube as well as on GoToWebinar. People who are finding any difficulty on watching the program on GoToWebinar can watch this program on YouTube. Viewers, I'd like to make a mention that Metalogic has come up with a new portal, which is mymetalogic.com. All webinars have been documented and converted into a report format, which you can easily find on mymetalogic.com. Do not miss to subscribe at 500 rupees per month. Just a short housekeeping before we get started. If you have any questions during the panel discussion, please type them into the question box in your GoToWebinar control panel. I'll bring them up during the presentation, and we will also have time for questions at the end. Always mention your company name and organization which you are representing, and who would you like to address your question to. We will also be having few audience poll questions, which I'm sure is very exciting, and our audience waits for it. So please attend the program till the end. Before we start, I would like to give a brief about the session to you all. As we are aware, steel is an alloy of iron and low amount of carbon. There are thousands of different types of steels which are created to suit different kinds of applications. These broadly fall into 4 types: carbon steel, tool steel, stainless, and alloy steel. Today, we will be deliberating an alloy steels that are made of iron, carbon, and other elements such as vanadium, silicon, nickel, manganese, copper, and chromium. Alloy steel display various environmental, chemical, and physical properties that can vary with the elements used to alloy. The proportion of alloying element can provide different mechanical properties. Having today's latest technologies in place and high-speed computers can foresee the properties of microstructures of steel when it is cold, formed, heat-treated, hot-rolled, or alloyed. This has given an extra edge to alloy steel manufacturers in the recent years. There are hundreds of products that can be manufactured with alloy steel of varying compositions. These include alloy steel pipes and tubes, alloy steel plates, sheets, coils, alloy steel bars, rods and wires, alloy steel forged fittings, alloy steel industrial applications, automobile, mining, machinery and equipments, railway, road construction, building, appliances and offshore applications. Going ahead with the latest PLI scheme in place to give thrust to the production of alloy steel within the country, we hope to witness more alloy steel plants coming up and a reduction in the volume of import as well. So with this basic introduction, I will leave the floor to the panelists. Today, our expert panelists are Mr. Gopalakrishnan, Ganesan, Deputy Secretary, Ministry of Steel, Government of India; Dr. Sanjay Kumar, Chairman and Managing Director, MIDHANI'S Limited; Mr. Sridhar Krishnamoorthy, Managing Director, Arjas Steel; Mr. R.K. Goyal, Chairman, Saarloha and Managing Director, Kalyani Steels Limited; Mr. Ramchandra Dalvi, Director Technical, Sunflag Steel; Dr. Anil Dhawan, Executive Director at Alloy Steel Producers Association, and I'm your moderator. Mr. Gopalakrishnan will be joining us in a while. Meanwhile, we have our first panelist. So we have our first panelist, starting from Dr. Sanjay Kumar Jha, Chairman and Managing Director of MIDHANI Limited. I would like to welcome you, sir. And I request you to please unmute yourself. Sir, over to you. Sir, we are not able to hear you. So I think there are two devices you have logged in. So you can try, unmuting yourself from the other device, because we are not able to hear you. Till the time Dr. Sanjay is trying to unmute himself, we will have first poll questions for you, audience. Let's have a poll. So on your screen, please be very, very active. So my first question to you is, on your screen, audience, please vote. How do you foresee India as a consumer of alloy steel produced in India? We have got 4 options. Extremely yes, yes, moderate, and can't say. How do you foresee India as a consumer? Remember, I'm asking you as a consumer of alloy steel produced in India. Is it extremely yes, yes, moderate, or can't say? People who are watching this program on YouTube can post their answers in the comment section. So we have got the results. So 44% of our audience are saying extremely yes. They do see India as a consumer market for alloy steel produced in India. 42% says yes, 11% says moderate, and only 2% says can't say. So this is quite a positive result. With this result, I would like to welcome Dr. Sanjay Jha. Sir, over to you.
Hello?
Sir,
Am I
yes,
audible?
sir, yes, sir, very much.
Hello?
Sir, please turn on your webcam.
I'm
Sir,
audible
please
now?
turn on. Sir, you're audible. Please turn on your webcam.
I'm audible.
Sir, you're audible. Please turn on your webcam.
Right. Okay. Just a minute.
Sir, you have a presentation. I'll make you a presenter.
Okay. Okay.
There is an echo coming from your side.
Yeah, I'm extremely sorry for some disruption here, but I think now it is okay. And
It is absolutely fine, sir.
presentation is already there on the screen. Can you give the presentation? I can start.
Sir, I've already given you rights to show my screen. You have a message on your screen. Can you see that? Show my screen.
Yeah, it is there. Yeah.
You need to click on that.
Okay. Right. Okay. So, fine. But the presentation is not visible here.
Not yet visible. You need to click on show my screen.
Okay. I'm not able
Okay,
to see here.
Let me give you the access again. Just a second.
I'm only seeing the email box is appearing.
Can you see the message
Only
on your
email
screen?
box is here.
Can you see the message on your screen?
Yeah, it's there.
Right. Your
If
screen is visible.
if some problem is there, then I can go. Just I'll not go to the presentation.
So your
I will
screen is
simply
visible to us. Just open the presentation, sir. Your screen is visible.
okay. So I do not know.
So just open your presentation.
Yeah.
So your PPT is not open.
It's not open.
Meanwhile, if you like to fix this, can we move on to the other panelists if that is okay?
Yeah, you can go to another one. I'll come back. Okay.
Okay, sure.
Right.
Just give me a moment. So we have our second panelist of the day, Mr. Sridhar Krishnamoorthy, Managing Director of Arjas Steel. I would like to welcome you, sir. Sridhar, sir, even you have a PPT,
Yeah, hi.
so I'll
Yeah, I
just give you the access. So keep your PPT open, please.
PPT
Yeah.
open.
Can you see my screen?
Absolutely, sir, it's visible.
Okay. So good afternoon, everyone, and thanks to Metalogic for organizing a special session on alloy steel. Quite often in this world of steel, we are not given enough importance or enough people don't know much about what we do. So this session is a good forum to exchange such ideas. So I have 10 minutes. So basically, I want to give you a small introduction to Arjas Steel, a couple of slides only. Then we talk a little bit on the markets, opportunities, and what challenges we have in front of us. And from our point of view, what is our outlook in the next coming months. So Arjas Steel, actually, we started off in Tadipatri. We have in Andhra Pradesh, we have a plant using the blast furnace route. We have 300,000 tons per year capacity. And we also acquired last year in November Modern Steel, and we are renaming it as Arjas Modern. And the Arjas Modern plant is about 150,000 tons. And this is using the electric arc furnace route. So we use scrap as the raw material. So combined, we have about, although both the plants are not yet at those levels, but rated capacity is close to 450,000 tons. So we combine, we have a range of products. Some of it is overlapping, some of it is unique to each plant. So we have rounds, RCS, hexagons, ingots, bright bar, heat-treated bars. Combined, we have about 2,500 people. And as is required for this business, we need to have strong systems-oriented way of working. So we have all the typical systems that you would find in most companies either in our customers or in our peers. So good management systems, tracing quality, root cause analysis. And increasingly what we have done in the last 2 years or 3 years is increasing the amount of digital solutions to make our business more efficient. So in different areas, we have implemented IoT solutions, which tackles specific problems in the operations. Coming to products, so you can see some of the products that we make. We have a range of products. Of course, we don't cover the entire range of what the alloy steel world is. That is due to some technical and other limitations, but increasingly our aspiration is to grow that profile. And on the right, you can see some of the applications where our steels go to. Apart from these automotive applications, we also have in the wind energy, in certain foundation bolts and some other engineering industries like textiles, we do have some special steel needs. And this is going to increase as India gets more quality conscious, as products become more sophisticated. Alloy steel applications will increase across metros, infrastructure, etc., and defense. Coming to the industry, so basically, give or take, India produces 100 to 120 million tons of steel, and year on year we vary between, depending on the situation, between 80 to 120. And we are exporting and importing approximately equal amounts, around 9 million tons of exports, and imports about 7 million tons. The last couple of years has been fairly good from an import perspective, because we have brought in minimum pricing and certain, you can say, protection for the local industry. So we are to some extent shielded, but more than that, I think globally steel is going through a good cycle. So in all the countries that typically imports come from, prices there are also equally attractive. So to that extent, import of steel is less. But definitely in a little difficult market condition, there's a lot of steel that finds its way to India. Among this 100 odd million tons, roughly 4 to 5 million tons, probably closer to 6 now, is what we call special steel. And this, of course, covers also a little bit of stainless, also alloy steel flat products. So if you take the products that we have, I have another slide that talks about that. We are talking about 4 to 5 million tons. Now, in the last few years, the government has been fairly proactive. And I think there are other speakers who will talk a little bit more on the policies, but definitely they have been consulting with the different industry associations and taking proactive actions to promote local production and local consumption, and also go up the value chain. So among this, the two most, I would say, attractive policies from an alloy steel perspective is the emphasis given through SRMTI on developing R&D activities to improve our product development capability. And secondly, the PLI scheme that was announced yesterday, which talks about import substitution. So essentially, these two are good building blocks. The rest, what you see in terms of export duty, import duty, these are more tactical and can tomorrow go away, because we do have to adhere to World Trade Organization and other principles. Coming to the market, definitely the automotive market, what you see in the red line is last year's monthly trend. And what you see in the blue line above that is the current year, so April, May, June, 3 months. And definitely we are trending well above last year's numbers, as well as if you see last year numbers, overall we have done a good, the last second half especially has been very good compared to even 1920. Commercial vehicles has been a little bit slower off the mark, but as economic activity improves, we expect commercial vehicle also to accelerate. If you look at three-wheelers, which is predominantly an export business, and to some extent has been impacted also by the lockdowns and closure of schools and tourism, is not doing as well as two-wheelers, which you can see has really performed extremely well. And this year as well, after the dip in May, has again bounced back. So we are seeing very good traction in the auto sector, especially PVs and two-wheelers. The farm sector has been extremely good, and the tractors has been phenomenal growth month on month. And last year was a very good year, and this year is continuing to be equally attractive as rural demand picks up, rural urbanization, rural transportation also happens with tractors. Tractor is no longer just an agricultural application, it's also being used for multiple other purposes. So the Indian SBQ market, as I was saying, what we are in, the market that we are in is 4 to 5 million tons. Half of it is automotives, energy, mainly wind energy, but also boilers and energy systems there, and off-highway vehicles, not only tractors, but also you can say earth movers and other equipment. And then railways is a smaller portion, and defense is even smaller. But generally speaking, in all these sectors, we have strong policies in place, and we are expecting a good, as long as we are not hit by further pandemic shocks, I think we are in for a good run. Energy sector, again, there's been a lot of thrust, both in the generation and also in the transmission. And the current budget forecasts a good amount of expenditure in these areas. We are seeing already in the energy a significant benefit from power availability aspect, but definitely in the transmission areas, we do have certain issues in, especially in Punjab, we are experiencing some difficulties, but by and large, this is expected to improve. And along with that, you will have growth in special steel requirements as well. The railways, again, is on a growth phase, both in terms of coaches as well as the springs and other things that are required for the coaches, where our special steel will go. And here there's an ambitious target to expand the coverage of railways, new railway lines, and also doubling and also going to high speed. There are, of course, so while...
Sorry to interrupt. You have 1 minute to go, sir.
Sure. So in terms of challenges, definitely there are challenges in terms of availability and pricing for the iron ore, which is one of the important raw materials for us, and also scrap. And you can see there, raw materials have jumped by 100+%, and the finished products have gone up only 22%, although it may seem that there have been a couple of increases, but in real terms, the price increase has been only less than 25%. What we look for in this alloy steel sector is we need more forums like this to exchange best practices, and we also have shortage of skills in certain areas. We need upgradation of that. And in terms of digitalization, we need to educate our workforce as to what are the potentials out there. I have a few slides here on various OEM plans, which I'll be sharing later on through the through Metalogic. But I'll just come to this last page. So the positives are it looks good in the short term. Short term meaning 21-22 year. We are looking at a good year going forward. We are also looking at these initiatives given by the government should encourage new capex to come in. And of course, the worries that we have are the pandemic. It's still not out of our system. And this is also impacting the supply chain, as well as the availability of raw materials is an issue. And of course, prices, of course, we'll have to pass it on to the customer. So how much of that we can pass on is also a concern. But overall, I would say in balance, we are looking at a good couple of years. And if we can manage our operations well, I think we are in it for a good run. Thank you.
Thank you so much, Sridhar, sir. I'm just... Okay, moving on to the next panelist. Dr. Sanjay, is it fine with your system now, as in your PPT presentation? You want me to present or you will be presenting? Sir.
You present from there. I think we are finding problem from this side.
Okay, okay. No issues. Yeah. Just give me a moment.
Yeah.
Are you able to see the screen?
Yeah, yeah. Visible.
So I'll just put it on slideshow mode. And the slides, you just have to tell me, to skip or move on.
Okay, okay, okay.
Sir, over to you.
Thank you. Thank you again. I'll first of all, I'll thank you for inviting me for this very important topic, that alloy steel. I have put the heading that I have talked about Indian alloy steel. true sense, a lot of equivalents you can see from international standard, but what I am discussing that whatever special work has been done on the alloy steel development that I am going to run through, and then my couple of slides here. The next slide, please. Next slide. This is only about briefly about the company which MIDHANI stands for. We are basically the 47 years old metallurgical and manufacturing company, and serving to the Ministry of Defense, coming in the Ministry of Defense and serving to the defense, space, aerospace, and other strategic sectors. Next, please. So I'm just trying to talk about this is the audience which is well known about the alloy steel. In fact, the alloy steel has a wide domain, right from carbon also is called as the alloying elements. And if you see the category, it comes even the cast iron also can be as alloy steel. But what we are discussing towards is the extreme right of my hand, that alloy steels, mostly the low alloy steels, high strength alloy steel, then micro alloyed steels. So a lot of changes have come in the alloy steel category, and that's why this topic has become very interesting and a very high value area also. Can I go to the next one? And just to run through that, what are the applications of the different alloying elements? In fact, today we talk about the steel, and whatever we say the primary or secondary steel manufacturing, mainly the basis is that alloying elements has given a big thrust on the application of the steel. And some of the important alloying elements are already tabulated here, and it's broadly what changes it is giving in the properties is mentioned. I'll go to the next one. See, what I am trying to focus here, that why the alloy steel has become very popular is mainly the core of entire manufacturing process is the melting. As you optimize the melting operations, that gives a tremendous push for application of alloy steel in the different categories. And this slide, what I am trying to focus here, electric arc furnace is well known, it is being widely used, but when it comes to the secondary applications, like when it is going to the vacuum induction melting, ESR, some case the vacuum arc remelting also, VAR, and in some case the combination of VAR and ESR. So what I say that all these combinations make the steel very special, and depending on the requirements, the different combinations I have shown here the different type of 6 different types of combinations here, by which the different types of secondary melting can be done, and we can have the steel of different qualities. The next one. Very broadly, this process flow chart I have just shown here, which includes, as I mentioned here, electric arc furnace, vacuum induction, air induction melting, followed by we have different type of VIMs, then VAR, and then downstream process of manufacturing, which is also very important. What process you follow, what is the heat treatment process. So these things are already shown here, and we have tried to cover the entire primary melting, secondary melting, forging, rolling. All I am trying to focus here on the very specialized grades of steel, which have a application in the space, defense, aerospace, and other strategic applications. The next one. The next one. And as we are all, in fact, it already given by our previous speaker about the different applications. So I'm not going on that category, but broadly, the areas where the commercial applications goes for, we start from the tool steel, then also we go for in the construction purpose, then automobiles is another major application area. And also we have certain steels like chromium steels goes for the roller bearings. So, and some place for the crusher plates. So what we are trying to see here, that the steel has such a tremendous application, which goes from a very small, the cutting razor blades to the very high-end applications, which makes the steel very special. And as you will see, and by the different speaker also, that what the importance is quite, application is quite big. Use application is there in the different segment of our manufacturing industrial process. The next one. And here the tungsten steel for magnets. Then also we have the nickel chrome steels for the highly stressed constructional parts. And austenitic nickel chrome steel is well known area, very big area of application. Then we have the chrome vanadium steels for springs, molybdenum steels for superheated steam parts. So these are the different areas where the steel has the applications depending on its chemical composition, processing, and thermomechanical history and heat treatments. The next one. And I'm just trying to bring it in the area of the very high-end applications. If you see the space applications, the core of the entire space, the rocket, the launcher, rocket like if you see the PSLV, GSLV, the MARAGING steel has a very important part in that, which takes care of its rocket motor casing. Then we are also using the high strength fasteners. And there are the different varieties. It comes in the form of the rings, plates, cold strips, hot roll bars. Also we use the wire, welding wire for making this rocket casing. Then we have the cobalt-free MARAGING steels for the ring plates, for rocket components. So wide variety of application is there for the MARAGING steel in the space applications. And it's very unique in processing and the technology. The next one. Similarly, just I am trying to focus on the other grade of stainless steel. If you see the stainless steel category, there one rocket, you see that right from the austenitic, martensitic, precision hardening, ferritic. So all the different domain, if you see the steel has a different applications and which drives our entire space program using this variety of grades. But whatever grade I have mentioned, it looks maybe very simple, but then the type of properties are required is also very unique and which calls for the special technique for melting, thermomechanical processing, and the heat treatments. And coming to the other another important segment of our defense program, if you see all the missile applications, again the steel has a very dominant role to play. And right from the Agni, Prithvi, and Akash, wherever these missile casings are there, again we have the applications of very high strength MARAGING steel for those applications, right? Rocket motor casing and all. The next one. So is the case for BrahMos and the Akash missile, where the application of special steels are very much there, and this calls for a very unique properties in the steels. The next one. So, and again coming to our the military requirements, if you see for the tank, the barrel itself has a very unique alloy steel, and also for this goes for the T-72 tanks, and there you can find out right from the torsion bar, then crankshaft, friction disc, everything, even the very simple grade of EN25 also has a very unique property requirements are there. And so is the case for trail tube and carriage components. So these are all used for very unique applications. Coming to our protection, which is going for the ballistic application, again, we have to depend on very unique properties of the steel. And there, some of the grades mentioned here, DMR 45, finds a very unique applications. And it calls for it is basically ultra high strength low alloy steel, which is requirements are very stringent as far as the clearness and resistance to laminar tearing against your bullet is concerned. And coming to the strategic applications also, there are varieties of grades used, and for the different components which has been shown here. Can you go to the next one? And not only that, components, even for the welding part also, the welding grades steels are very unique, and it calls for a very unique process in manufacturing, right from the primary melting, secondary melting, refining, and then in the process of processing and all. Next one. Similar thing for if you see the nuclear applications going for our pressurized heavy water reactors, the various grades are mentioned here. And you can see right from the normal 316L, 304L, even though it looks a simple 316, 304L, but their properties and processings are very unique because the reliability of the components should be of the highest standard, as well as free from certain elements, like let's say from the cobalt, because it goes for the radioactive applications. Next one. Similar is the case for, I have shown for the other one, like 316LNL, the grade requirement is very unique there. Then 321, then we have 304 nitric acid grade steel, even though it is 304, but its control of chemistry is very unique, and it has a very special application in the fuel recycling. And so is the case of MARAGING 350 also. Again, for the PFBR, a prototype fast breeder reactor, which requires a very unique property in terms of resistance against the high radiation dose. And that is where you can find a lot of the required of modified 316Ti in form of the D9 and and of course 316LN. So a lot of grades. Then another one is the 168-2. Then for billets for tubes for a steam generator, 9 chromium 1 moly steel, grade 91 welding electrodes. So you can find out everywhere the steels are the unique, and also the alloying elements also will be different in those the requirements. The next one. Next one, please. And I have put it for the fusion reactor. This is also a very unique program where indeed the steel again has to play a role of neutron shielding, and a grade called 304L boron. So boron modified steel is there, where by adding the boron in the steel, high content of boron, these properties can be met, but this requires a lot of challenge in processing, because once we put the boron in the steel, its working process, workability is a different type of requirements, and which calls for a process. Another one is that RFMS steel, they're all microalloyed steel, and a lot of control and chemistry is there. And again, light water reactor, a very, again, a unique type of reactors, and variety of alloying steel you can see here. Whatever I have mentioned so far, all those steels, what I am shown here, they basically indigenized, and it is almost, you can say that Indian alloy steel. So a lot of modifications have been done in terms of the chemistry and the processing technology and the heat treatment, and that's why we call a total indigenous development is here. Next one. Similarly, for the power sector, the MIDHANI has done a lot of work, and there these grades have been developed, and you can find almost a dozen grades are there, and which right from austenitic stainless steel to the martensitic, ferritic. So a lot of developments are there, and some of the duplex one. Next one.
Sir, you have 1 minute to go.
Yeah, I'm closing now. Next one. And in spite of making so many grades and our steel production, I see I'm just trying to put one data here that even though we have, we are importing almost an average, if you see the last 3 years, we have imported the 22,000 crores alloy steel per annum, but our export also is 14,000 crores, but a deficit of 8,000 crores also is there. And I am sure that the type of, our primary steel sector is very, very strong. It is possible to enter the secondary steel also, and it is possible to bridge this gap of 8,000 crores. Rather, we can have the net exporter of the alloy steel, where there's a lot of potential in the international market, for at least in the area of defense, aerospace, and other strategic sectors. Next one. Just to, again, the same data here. Next one. And among total, if you see the import, what we have tried to analyze, mainly the stainless steel in the flat products are imported in the bigger, higher width. And that is where I said it is possible to have bridge the gap. And I'm just trying to say that we are already set up a wide plate mill of 3-meter width, where we can roll the various grades of alloy steel, super alloys, and titanium grades can be done. And I think that will be a good support where we can reduce the import of the alloy steels. Next one. And of course, whatever steel I have mentioned requires a lot of high quality, and there the vacuum induction melting is very important. And just I am showing a furnace here, which is a primary melting, which can give this the special requirement for the steel as far as the strategic areas is concerned. Next one. So as already pointed out here, that PLI incentive scheme which can be done for the alloy steel will be really, it will help us, and it will also improve the India's performance in the export market, and this will be a good value addition for the country in Indonesian of a special steel in the country. Next one. Next one. So thank you very much. I think this is what I wanted to report with this August panelist.
Thank you so much, sir. So I hope the PPT is closed and you are having a, panelist.
Yeah, it's closed. Yeah.
Okay. Okay. So moving on to our next panelist, we have Mr. R.K. Goyal, Chairman, Saarloha, and Managing Director of Kalyani Steel. Goyal, sir, if you allow me, can I take one poll question?
Yeah, please.
Okay. So audience, on your screen, I'm raising one poll question. Please vote very, very quickly. The question is on your screen. The question is, what is the major hurdle for producing alloy steel in India? We have got 4 options. One is high cost of raw material production, cheaper imports, FTAs from FTA countries, unavailability of technology, or unavailability of consistent demand. Please vote very, very quickly. And people watching on YouTube, please post your answer in the comment section. What is the major hurdle for producing alloy steel in India? High cost of raw material and production, cheaper imports from FTA countries, unavailability of technology, or unavailability of consistent demand. So we have got the results. Results on your screen. 47% of our audience feels that high cost of raw material is the problem to produce alloy steel. And the second highest, we have got unavailability of consistent demand, which is 17%. 19% says unavailability of technology, and 16% feels imports. So the majority feels 47% high cost of raw material. So moving on to our next panelist, I would like to welcome you, Goyal sir. Over to you, sir.
Thank you.
So you have a presentation.
Yeah.
So is it open? I'll just make you
yeah, please open the presentation.
So I'm making you a presenter. You will get a message on your screen to show my screen. Right. So your screen is visible. Just click on your presentation.
Okay.
So on the right, I think it is there. Yes. You can put it on slideshow mode, sir. Over to you.
Good afternoon, everyone. First of all, thank you very much, Monica, for inviting me to make this presentation as part of the panel discussion. I like to bring just a couple of points in my presentation for the notice of complete audience and panelists. First of all, during last 7 years, the global steel production has just gone up by only 212 million tons. from 1652 million ton to 1864 million ton, while Chinese production has gone up by 231 million ton, which means basically global production is shrinking and China is producing more and more, and even Indian production has gone up only by 19 ton with an average of around 3.1% CAGR. Now there are two things, there are two aspects of this. One is the last 7 years the growth was less, so we should not be expecting much higher growth. But the way the situation is in our country today, the way the ambitious plans we have of producing around 255 million by 2030, the way government is coming out and supporting manufacturing, and one of the thing is this PLI which has come, which means Indian steel industry will grow much faster than what it has grown during last 7 years or last 10-year time. So we are going to have a good time where the industry is going to grow much faster as compared to what it was last and as compared to most of the countries globally. Now it may be China and India may or is likely to supersede the growth rate of China. Now, another thing which I like to bring, very important point, is we have a minuscule total consumption of engineering steel long products. I am not including flat products as compared to what it is consumed globally. We consume only around 4 million ton of SBQ quality bars, and beside that around 1.2 million ton of wire rods, which is largely used as an engineering steel. Of course, wire rods are used for several other applications. That is different. And major part of this engineering steel is used in our country by way of forging and largely in auto industry. Now, out of this 5.2 million tons, if we look at the growth of auto industry during, sorry, I lost my presentation.
So your presentation is visible to us. You just need to click on the screen and move left and right cursor. Do you want me to make you presenter again?
Yeah,
just
please.
one. Yes, just 1 second. Are you able to see your presentation now?
No, I'm sorry, no.
Sir, can you open it once again from your system?
Okay. Yeah.
Sir.
So it is vanished once again when I click that show my screen.
So is it visible to you?
No.
Okay. Let me try again.
Yeah. But the moment I like to change. Yeah. Now, one of the important application, as I mentioned. Oh.
Sir.
It is disappearing once again.
Sir, but we can see, yeah, you're talking about EV production and sales in India.
Yeah, okay. Let me continue then. Okay. One of the key important application, as I mentioned, is automobile production, where we consume almost 60 to 70% of engineering steel or SBQ quality steel. And out of that, a good portion is consumed in passenger cars or passenger vehicles as well as two-wheelers. Now, if you look at the production of passenger vehicles, we produce around 20 to 25 million two-wheelers and around close to 4 million passenger vehicles. Of course, last couple of years, because of the pandemic and because of the lockdowns, the total production has gone down. But if you look at the EV sales, till now, there is hardly any penetration. There is negligible production, whether it is two-wheelers or whether it is four-wheelers. But that is not the situation which is going to remain. Please move to the next slide. EV impact on alloy steel requirement. Yeah. So if you look at the EV production and sales in the country, as I mentioned, till now, there is not much which is happening in the country. But going forward, these are the projections by SIAM. By the year financial year 25, the total production of two-wheelers is likely to be around 18 million, which is not as much as what it used to be. And for four-wheeler, it is only around 3.2 million. But if we look at EV production of two-wheelers, it will be almost 30% of electrical vehicles. And as far as four-wheelers are concerned, it will be still not a great percentage, but it will be 7 to 8% still. But by 2030, the two-wheeler production, EV two-wheeler production will be almost 70%, and the EV production of four-wheelers will be almost 1/3 or around 30%. Now, this indicates that the major part of engineering steel, which is consumed by these two sectors, two-wheelers as well as four-wheelers, is not going to grow. And if you look at the total consumption growth for four-wheelers by 2030, it will get stabilized, and there will be not much growth, and subsequently the degrowth will start. As far as two-wheelers are concerned, there will be degrowth which will start now, and by 2030, we will have only 75% of the requirement what it is today. Similarly, the commercial vehicles, if we look at passenger vehicles like the buses, most of the city buses, intercity buses, they are going to be electrical. As far as long duration, intercity or long distance buses, they may still continue to be based on IC engine. But slowly, as with a sector which is the largest consuming engineering steel, the demand will stagnate and then will start going down slowly. Now, this only indicates that we really need to focus, as manufacturer, we really need to focus on non-auto sectors, and which are plenty, and where the growth rate is very high, whether it is engineering, whether it is defense, whether it is energy, aerospace, or space. Now, these are the sectors which are growing anything between 15 to 30%, and we need to set up facilities for catering to these sectors. Now, as Saarloha, we have already set up fairly large facilities to cater to these requirements, like beside having an electric arc furnace, beside having blooming mill, a very large rolling mill, we have secondary remelting facilities like vacuum arc remelting, 2 ESRs, and we are already approved by most of these customers and are catering to this requirement, which is growing fast. And as like MIDHANI is a pioneer in this, they are doing very large, but slowly our volumes are increasing in this direction. At the same time, there are commodity steels which are required. We have integrated steel plant as part of Kalyani Steel in Hospet. There again, we are increasing capacities for taking care of requirements of different sectors like in powertrain, bearing, seamless tube, and which are largely going for energy sector and all. So the focus is shifting, and focus need to shift from auto to rest of the applications, and that's where the alloy steel demand will move. Thank you.
Thank you so much, Goyal sir. And it is, I hope the screen is removed from your side, as in the panelist view is there. Okay. So moving on to our next panelist, we have Mr. Ramchandra Dalvi, Director Technical, Sunflag Steel. Ramchandra sir, I would like to welcome you and please keep your presentation open. I'm making you a panelist, presenter, sorry. Yeah. Can you see the message on your screen?
Yeah.
Okay, okay.
ये करेगा ना slideshow.
Yes, sir. Slideshow.
Yeah, thank you for having me in this webinar. And I am Ramchandra Dalvi, Sunflag Steel, trying to present on application of alloy steels. My presentation will be a little faster, sometimes at rapid fire mode, because the number of slides are more and I have to finish in 15 minutes. I will be taking exactly 15 minutes. Thank you. Now, as you know, steel is...
sorry to interrupt. You only have 10 minutes, sir.
Okay. Steel is an interstitial solid solution of iron and carbon. Iron being the matrix and carbon being the interstitial solute. Normally, the classification of steel is such that if the total alloying elements are less than 1%, it is called plain carbon steel. Little bit here and there is okay. Lower alloy steels are 1 to 5% total alloying elements, and high alloy steels are more than 5%. Some of the elements which are substitutional are added for the following reasons, which are given in this. For example, aluminum for deoxidation, manganese for toughness, chromium for wear resistance, and moly for strength and hardness, and so on. I will be covering here the following grades: low alloy steel, construction industry steels, automotive industry steels, high strength low alloy steels, defense application steels, oil and gas industry steels, energy sector steels, tool steels, valve steels, stainless steel, maraging steels, super alloys, and clean steels. Now, most alloy steels, the engineering component require good response to heat treatment, which is to develop hardness up to required depth. Hardenability is capability to develop through hardness and is a function of composition, while for a grade, specified composition range is broad. Much closer tolerance is required to ensure hardenability. Carbon plays an important role as alloying elements form carbides with carbon, which alter hardness and ductility. The shape of carbides influences property like hardness, ductility, and toughness, and the loss of carbon due to thermomechanical treatment is termed as decarb, which is undesirable. The types of alloy steels, low alloy steels, 1 to 5% total alloying elements, and for high alloy steels, more than 5% total alloying elements. Stainless steels, tool steels, valve steels, super alloys are all high alloy steels. Applications of alloy steel, for example, in construction industry, there are 3 types: steels for fabrication, welding, and riveting, steels for concrete reinforcement, and steels for concrete reinforcement in corrosive conditions. Now, this is the first one, the fabrication steel. It is hot rolled, medium, and high tensile, and flat products being plates, strips, flats, and bulk flats, sections, beams, channels, angles, etc., long and square bars, welded, bolted, and riveted structures. For the concrete reinforcement steels, there are 3 criteria. One is carbon equivalent. The second one is 0.2% proof stress, percentage elongation, and bend test. These are the 4 parameters on which the properties will work. And it will be certified under the names of FE 415, 500, 550, and 600, the suffix being the 0.2% proof stress. This is a similar requirement, but only in this case it is stainless steel because it is corrosive environment. Now, steel for automatic applications are normally engines, motors, transmission, gearboxes, drivetrains, steering systems, and diesel engine parts. Now, these are some of the pictures which show the engines, and various parts are indicated there with the grades therein: connecting rod, camshaft, crankshaft, piston pin, valve steel, crank pin, rocker arm. Also for transmission and gearboxes, gear steel, bearing grade steel, UJ cross steel, axle shafts, and suspension. For drivetrain and steering systems, rack and pinion system, front axle beam, steel for drives, stub axle again. I have lost my picture. Okay, over here. Huh?
We are able to see you're on chemistry of automotive grades.
Yeah, but this one here.
It's the second one.
Yeah, sorry. Now these are the chemistries of the grades which I have indicated earlier with parts. Now we come to high strength low alloy steels, which are also called HSLA steels, normally having low carbon, manganese between 1.5 and 2%, and less than 1% of elements like niobium, vanadium, titanium, moly, zirconium, or boron. They are weldable, formable, they have high strength, they have high strength to weight ratio, and cost is very low because of low alloying and no heat treatment. It has got good fatigue properties, creep resistance, and low temperature impact. The applications of HSLA steels are in oil and gas pipelines, heavy-duty vehicles, storage tanks, transmission towers, mine and railroad. These are some of the defense grades which are of low alloy type. Some of the grades which are high alloy type for missile application. For oil and gas, we normally require high strength steel with high resistance to corrosion, and the structure being mostly tempered martensite, and chrome moly or chrome nickel moly alloy steels take care of this lean applications. Whereas for higher end applications, martensitic stainless steels, precipitation hardened stainless steels, and duplex stainless steels take care of the application. These are some of the, in oil and gas industry, these are some of the applications. The upper ones are the lower end applications, the bottom ones are the higher end applications. You can see that upper ones are mostly low alloy, where the lower ends are stainless steels. Now next we come to energy sector. Here in this table, the process sequence for each mode of energy generation is shown: thermal, hydel, nuclear, wind, and solar. But the steel requirement is only for three major parts of these process requirements. One is for boiler, the other is for turbine, and the third is for generator. Now, some of the boiler plates specifications with carbon related with thickness. Some of the standards for boiler plates. Now we come to tool steels. Tool steels are high quality steels made to control chemical composition, processed to develop properties useful for working and shaping of other materials. The carbon content in tool steels may range as low as 0.1% to as high as 1.6%, alloying elements being chromium, moly, vanadium, and tungsten. Normally, tool steels offer toughness, wear resistance, hardness, and heat resistance. The nomenclature in tool steel is such that the application denotes the name. For example, water hardening tool steel as W, shock resisting as S, oil hardening as O, and so on. The role of elements, the hot hardness is imparted by tungsten, moly, cobalt, vanadium, chromium, manganese. Wear hardness by vanadium, tungsten, moly, chromium, manganese. Hardenability by manganese, moly, chromium, silicon, nickel, vanadium. Distortion, minimum distortion by moly with chromium and manganese, and toughness by vanadium, tungsten, moly, manganese, and chromium. This is a table which indicates the types of tool steels with major grade therein, with applications and major alloying elements. I will not read this because of paucity of time. Now next come to engine valve steels. It is one of the most critical and precise part of any IC engine. And the valve is the device to open and close a passage. In this, the animation shows the firing sequence and the operation of exhaust and inlet valves with the picture of the valve steel item. Now there are two valves, the inlet valve being less critical as compared to exhaust, because the exhaust is subjected to very high temperature. So obviously the steel choice is according. Now these are some of the chemistries which are given here of engine wall steels. Now we come to stainless steel. The types of stainless steels are austenitic, ferritic, martensitic, duplex, and precipitation hardening. The austenitic stainless steel, some of the chemical compositions are given here. It is considered to be the environmental friendly steel par excellence, and it absolutely has no problem about magnetism or rust formation or anything like that. The uses are given herein. Ferritic stainless steels normally used for only the corrosion resistance property of it, very soft. The uses are indicated over here. Stainless steel for martensitic stainless steels are for engineering applications because they have mostly tempered martensite structure, and the items are indicated here. Duplex stainless steels have very high strength and take care of higher end applications. Chemistries are given and the uses are given. The precipitation hardening steels, 17.4 pH and 15.4, 15.5 pH. They are basically very high grade applications like aircraft applications, valve parts, landing gear parts, etc. The maraging steel, we come to maraging steel now. Maraging steels develop high strength and toughness without losing ductility. And this is achieved by precipitation of intermetallics with nickel as the principal alloying element and cobalt, moly, titanium, or aluminum as the secondary alloying element. You can notice the tensile strengths. They are 2 to 3 times that of alloy steels. The applications of maraging steels are in the rockets and missiles, gas centrifuge for uranium enrichment, high wear die components, fencing blades.
Dalvi, sir, you have 1 minute to go, sir.
Okay. Then I would like to come to an important part, which is the clean steel. Just a minute. The clean steel, the performance of steel is dependent on chemistry and cleanliness. All steels have inclusions. Inclusions are non-metallic, affect performance, and have to be removed at liquid stage. Inclusions cause premature failures, fatigue failures, initiate and propagate cracks. Therefore, process must be designed to prevent formation of inclusions, facilitate macro inclusions to float, and engineer micro inclusions to float quicker. This is the technology of clean steels. Clean steel technology ensures process which can consistently produce high quality steel with targeted low gas and inclusion level. Inclusions are classified as A, sulfide type, B, alumina type, C, silicate type, D, oxide type. It is the oxide or alumina which are the ones which have to be engineered, as sulfide can be brought down by control on sulfur and oxygen, and silicate can be brought down by making aluminum cage steels. India imports a lot of alloy steels due to difference in quality and performance. One of the major causes of gap is the inclusions. With Atmanirbhar scheme of the government, inclusion management has become need of the hour. Sunflag Steel since 2017 has taken steps to make rapid progress in this direction and has achieved low gas and inclusion results. Toward this aim, Sunflag Steel and Dido Steels have been carrying out joint project at Sunflag. The steel making and casting processes were engineered to have the following aims: best refining practice to aim low oxygen, no addition of calcium, avoid reoxidation, change shape and volume of condition to get low erosion and good floating of inclusions, and manage accurate range of pouring temperatures. Now the following grades were targeted: steel for crankpin, steel for gears, bearing steel, and hub bearing steel. These are the results which we have achieved consistently, and these are in about 75-80% of our steels. These results are obtained in these grades. Oxygen we have achieved ball bearing steel 6 ppm and steels for gears and crankpin 7 ppm. Sunflag now aims to be a leader in the field of clean steels. Thank you for your time. I conclude my presentation.
Thank you so much, Dalvi, sir. Thank you so much. Moving on to our next panelist, quickly we have Dr. Anil Dhawan. He's the Executive Director at Alloy Steel Producers Association. So over to you, sir. You want me to present your slides? So just 1 second. Yeah, I've unmuted you.
Good
Okay, so
afternoon.
I'm opening your presentation, sir.
Yeah. Before we start, good afternoon, everyone. Good afternoon, eminent panelists and Monica. I must thank Monica and Metalogic for bringing all of us together on this seminar and a portal. And as in the beginning, Mr. Sridhar mentioned, alloy steel is something which is, talked little, but works more. So it is a low volume, low tonnage, but very high value and very high strategic importance. And that's why we compliment your Metalogic for having brought us together and to the audience. Having talked about it, I also must say that I am reminded of some seminar earlier in the year when you brought us together again once on